Hello and welcome back. The following problem states diethyl ether is a volatile, highly flammable organic liquid that is today primarily used as a solvent. The vapor pressure of diethyl ether is 401 millimeters mercury at 18 degrees Celsius. Its molar heat of vaporization is 26 kilojoules per mole, and the following problem states to calculate its vapor pressure at 32 degrees Celsius. The very first thing that we need to do when approaching this problem is we need to convert the temperatures from Celsius to Kelvin. And also it's important to identify which of the two pressures that we are solving for. In this case, we are solving for P2. Well, in order to do so, the two temperatures are now going to be, for temperature 2, this is the 32 degrees Celsius, we add 273.15 to the temperature, which will give us 305.15 Kelvin. For T1, this will be equal to 291.15 Kelvin. Well, once we do that, the other thing that we have to take note of is to also convert the delta H of vaporization that they gave us to joules per mole. That is because R has units of joule per Kelvin mole. So the delta H of vaporization will be equal to 2.6 times 10 to the 4th joules per mole. Well, once we've done that, we can then start to plug into the equation and start solving for P2. Well, the very first thing that we have to do is we can go ahead and plug everything into the right-hand side of the equation before we simplify further. And so we have 2.6 times 10 to the 4th joules per mole divided by 8.314 joules Kelvin mole. Mole and mole, joule and joule cancels out. We have over here 1 over T2, 305.15 Kelvin minus 1 over 291.15 Kelvin. And this will simplify it down to negative 0.4928. And once you simplify this, Kelvin and Kelvin will also cancel out. As you can see, this is unitless. In order to take the inverse of ln, we put everything to E. So we'll simplify this down to P1 over P2 is equal to 0.6109. We can multiply each side by P2, multiply by each side by P2, that'll cancel, divide by 0.6109, 0.6109, and then this will simplify down to the pressure at 32 degrees Celsius or 305.15 Kelvin is going to be equal to my initial pressure, which is 401 millimeters of mercury divided by 0.6109, and then this will give us a final pressure of 6.6 times 10 to the 2nd millimeters of mercury for our final answer. It is very important when approaching these problems to always make sure you double check your math, and you can go ahead and plug in this new temperature, this new pressure back into the equation and solve for T2 to make sure you get the same temperature. It's also important to make sure you watch your canceling of units and to make sure you're solving using the appropriate algebraic steps to solve for the appropriate unknown variable. Thank you.